Hi, I want to take this opportunity to talk about what the team members of RUMarino have developed. RUMarino is a multidisciplinary team from the University of Puerto Rico at Mayagüez, who developed its own autonomous underwater vehicle, AUV for short. Our first AUV is called Proteus. Proteus has competed 3 times at RoboSub. The first time it won Rookie of the Year and the Perseverance Award. The second time it won the Perseverance Award again. And the third time it finished 15 out of 72 teams in the competition. Right now we are developing our new AUV called Hydrus. Hydrus is a bigger, more capable AUV made to compete at the highest level. These are the team members of RUMarino.
In the Mechanical Structures Division, we focus mostly on the physical construction of the submarine, designing its structure while keeping buoyancy, weight distribution, material strengths, and future additions in mind. We are currently developing our newest submarine, which will provide a foundation for future additions and capabilities, such as integrating a torpedo launcher, an articulated gripper, or a DVL sensor. It will also circumvent difficulties in the previous design by coating its 3D printed parts in a photo-curing resin to effectively waterproof them. All in all, our new sub will surpass our previous design and give us an edge in the competition.
In the electric division, we are in charge of delivering the power to the different electronic devices in the AUV. In addition, we designed the printed circuit board, or PCB for short, to make the electronic the most modular possible and make them work in the most efficient way, while also reducing the noise on the circuit communication. As a more recent accomplishment, we designed a new PCB that will be in charge of delivering the power to the AUV and make the router into a buoy so it can stay closer to the AUV while eliminating the excess of Ethernet cable. For the future, we expect to keep upgrading our circuits and connection to be even more modular and efficient.
The Embedded System Division is in charge of creating the link between software and hardware. With the use of an Arduino, we receive inputs from the various sensors of the AUV, while sending signal to thrusters and actuators. Our focus this year is to create a code that controls the gripper and the torpedoes, and potentially be able to maneuver the AUV with a remote control. However, our main priority being the Arduino code and have the sub run with 8 motors.
The Operation Division optimizes work structure. Its purpose is to maintain the team functioning correctly as it grows in scope and in members. The team also leads communication with possible sponsors and maintains them. Recently, we have given a new purpose to our documentation in order to assure the transfer of knowledge to future RUMarino members. Along with the Business Division, it relieves administrative responsibilities from the team. The Business Division manages the team resources, such as revenue streams, documentation, and inventory, which keeps the team running efficiently. This team is also responsible of finding opportunities to promote Hydrus and STEM fields for students in elementary, intermediate, and high school.
The Software Division in RUMarino is responsible for developing and maintaining the high-level code for our AUVs, as well as integrating codes from the other divisions into the main architecture. Our most common language for high-level coding is Python. Additionally, we use the ROS library to handle parallelization of processes. Our current goals are to salvage code from our retired AUV and develop a new architecture from the more robust and modular components for our new sub, Hydrus. We hope to improve upon the designs and work of past members by working our old code into more robust solutions.
Control Division is in charge to develop control system of our AUV using Python code and ROS. As of now, we are using a PID control system to help our AUV move in different directions. Our challenge is to make all the movement with all the degrees of freedom that our AUV can do. In addition, we are working with our Victoria motors to integrate the pitch, roll, and sway movement that will make the AUV more dynamic. Due to the pandemic, we developed a simulator using Gazebo. This way we can test and verify our code to work properly and have more ways to continue to improve our development and achieve more goals.